Welcome to the lecture on specific weld cracks. So, in the last lecture we talked about hot and cold cracks, and we also discussed among them the liquefaction cracking also. Now, we will talk about some specific weld cracks, and that these names are given because of the positions or their orientation and shape and so. So, hot and cold cracks in weld metal and HZ and base metal are given different names depending on their location and orientation. So, you have these cracks only, but if they are they may be in the weld metal, they may be in the HZ, or they may be in the base metal, and they can be given the different names where they are located, how oriented they are. So, these are normally depending upon their orientation. See, you have the longitudinal cracks or transverse cracks, then you have the crater cracks or underbid cracks, and then you have also toe cracks. So, longitudinal and transverse, if you look at, they are depending upon the orientation, that how they are oriented. Similarly, crater cracks will be because of the crater position, then you have underbid, and these toe, they are because of the positions and all that, their location. So, that way you have these cracks, and we will talk about these cracks in somewhat more detail in this lecture. So, coming to the crater cracks. So, basically we are talking about the weld metal cracks, and if you talk about the cracks which occur in the weld metal, then in that category we have the crater cracks, longitudinal cracks, and transverse cracks. So, first of all we will talk about the crater cracks. Now, crater cracks occur when welding is interrupted. So, basically this is so welding is interrupted. So, they are usually star shaped and progress only up to the edge of the crater, also known as the paw cracks. So, if you look at the crater cracks, so this is typically the example of the crater crack. So, this is the if you look at this, see, this is the star shaped cracks which is there inside, and is a crater position. So, you will have these they are also known as the paw cracks because their resemblance is like the paw of the birds. So, that is why they are also known as the paw cracks. So, they are usually star shaped. So, what you see is that they are usually in the shape of the star, and then they will be progressing up to the edge of the crater. So, normally that is the trait of these crater cracks. So, these cracks basically their attribute is that they are many a times they are the starting point for the longitudinal cracks, about which we will see, that is you see that is how they will be starting. So, normally you will have the end cracks defined like this. So, they are basically the starting points for the for the longitudinal cracks. So, from here these longitudinal cracks basically will be moving. So, they are here, actually this is going towards the end. So, that is your end crack. So, your this crater crack will be extending into this weld metal, and this becomes a longitudinal crack. So, that is what this figure shows. So, what is happening in the crater cracks, what you see here. So, either you have the paw shaped star shaped cracks, or you have what you see here. So, this results into the formation of these longitudinal cracks. So, normally these crater cracks will be started when you are stopping somewhere, and then further you are restarting. So, in those cases you will have the appearance of these star shaped cracks. Now, they are normally found when so if you talk about the formation of these crater cracks. So, they are frequently found in the weld metal that has a high coefficient of thermal expansion. So, normally when you are welding any material which has very high coefficient of thermal expansion like austenitic steel. So, in those cases your crater cracks are very likely to be found. Now, we have discussed about the crater cracks, and they so they can be prevented. So, what you see these crater cracks, so they are basically prevented by the starting the each weld properly, because they are likely to occur because you are your electrode is ending and then you are taking another electrode. So, at that point it is likely to start. So, basically at that point you must do something to fill those crater points. So, that is how you can prevent the formation of these crater cracks. Coming to the another type of crack. So, another crack is the longitudinal weld metal cracks. So, among the weld metal cracks we have as we have studied, we have three types of cracks. We have the crater crack, you have longitudinal weld metal crack, and you have the transverse weld metal crack. Now, the longitudinal weld metal crack, they usually run through the center of the weld, often an extension of the crater crack formed at the end of the weld for fillet weld. So, you can have a view of these fillet welds. So, this way these longitudinal crack looks like. So, normally and if your crack goes in the normal weld. So, this is the example of your longitudinal weld metal, longitudinal crack through the weld bead. So, that is how it looks like. So, longitudinal crack at the surface of the weld metal can be extension of crack started deep down the joint, mostly in the root zone. So, that is mainly in that fillet weld where we have seen. So, here in those cases you can see here it is seen that these longitudinal cracks which are formed at the surface of the weld metal. So, they are the extension of the crack which started deep down that the joint, mostly in the root zone they start, and then they move longitudinally in the and that is how these longitudinal or center line cracks are basically formed. So, the thing is that you must have the proper for that not to happen, your root pass must be made very carefully to avoid the formation of these longitudinal cracks. Then coming to the another type of crack, that is your transverse cracks. So, as we know that if it is parallel to these bead, then it is the longitudinal crack, and if it is in the perpendicular direction, then it is known as the transverse crack. So, if you talk about the transverse crack, these cracks run across the weld perpendicular to the weld axis. So, if you look at these transverse cracks, we yesterday also we discussed. So, this is how this is your weld axis. So, these cracks will be normally running. So, they are across these or the perpendicular to the weld axis, their movement is. So, and in many cases if you see, they may extend beyond the weld metal and they may go even into the base metal also. So, also these they commonly occur in weld joints that are tightly restricted, so that the structural section or weld metal cannot shift to relieve the built up stresses. What we have studied earlier, that many a times when there is a restriction imposed. So, then in that case it is very difficult for the stress to be relieved. Now, in those cases when you have in those joints where you have the tight restriction and there is no possibility of the movement. I mean for the accommodation of these stresses which are building up. So, in those cases these transverse weld cracks, weld metal cracks they are likely to come. So, these are normally these are the often the shrinkage cracks produced when the weld metal is cooling and contracting. So, that is what basically normally, as we have seen that on the sides you have the heating and then further cooling, and if you have the restraint on the sides, in those cases these restraints will build up the stresses, and those stresses, if they are reaching beyond certain limit beyond the strength of the material at that condition, then in those cases you have the possibility of having the transverse weld metal cracks. So, this is the example of the transverse, this is the figure for the transverse weld metal crack. Now, we will come to the base metal cracks. Now, normally we have talked about so far about the weld metal cracks. Now, we talk about base metal cracks. So, normally they will be occurring in the base metal. Normally, they will be usually located in HZ and run parallel or perpendicular to the weld bead. So, normally they occur mostly when the HZ becomes hard and brittle, and that may be because of many reasons. And so, you have the existence of these different types of base metal cracks, and they are of different categories, like you have the longitudinal base metal cracks, you have transverse base metal cracks, you have the underbid or toe cracks. So, that is what normally is because of the positions where they are occurring. So, if you talk about the longitudinal base metal cracks, so as we have seen that you have a longitudinal weld metal cracks, so that will be in the weld bead, but in these cases these longitudinal base metal cracks, so they will be parallelly running to the weld, and they will lie in the base metal basically. So, so what is happening? So, they are they will appear like, so if suppose you have the weld bead appearing like this, and this is your this side your base metal, it is there, and this is your weld metal. So, and this is your this side your is base metal. So, in that base metal you have cracks appearing like this. So, this this type of cracks which is there in this base metal zone. So, they are known as the longitudinal base metal cracks. So, they are basically they are formed as extension of these bond line cracks, and this is due to the poor weld metal penetration into the sides of the butt joint. So, if you talk about the fillet welds, so for fillet welds, so for for fillet welds, these longitudinal base metal cracks, they are divided into two groups, and one is that which start at the toe of the weld. So, start at toe of weld, and another is that root cracks. So, which proceed from the root of the fillet weld. So, depending upon their position, you have either they are starting at the toe of the weld, or which proceed from the root of the fillet weld, and they go into the base metal, and sometimes they even go out of the other side of the joint also. So, that way you have the significance of these longitudinal base metal joints. Now, in the case of, if you talk about these longitudinal base metal cracks, so if you talk about the butt welds. So, crack which is there in the base metal, they are likely to show up in the heat affected zone, at the very edge of the that fusion zone, which is well in that fusion zone, boundary zone, and between the weld metal and the HHZ. So, there its presence can be seen. Now, this can be attributed to the hardenability property of the steel. So, whenever you have the steels with higher hardenability, that is what we have studied earlier. So, in those cases they are more likely to be to be seen, because that cannot accommodate the stresses, and in those cases the cracks are likely to be to be seen. So, you should have the proper combination of the weld metal and the filler metal. So, that is so basically that hardenability basically you have to avoid. So, so what we do normally to avoid the formation of these longitudinal base metal cracks is that many a times what we do is to overcome this, many a times what we do is that we make a transition joint by buttering up the joint face. With very ductile electrode, and using different electrode to finish the weld. So, this is what, because in that case if your there is ductility induced, in that case it is it is likely that there will not be occurrence of this kind of defect, that is your longitudinal base metal cracks. Then comes the transverse base metal cracks. Now, here also similar to the longitudinal base metal cracks, in that case you have the cracks in the seen in the transverse direction. So, again you will have the weld beads, weld metal zone, and in this weld, in this base metal zone you have the cracks which will be seen like this. So, this seen this shows the transverse base metal cracks. So, they are developing perpendicular to the weld axis. So, as you see that this is developing perpendicular to the weld axis, and normally they are associated with the welding of high hardenability steels. So, normally when you do the welding of tool steels or certain alloy steels which are highly hardenable, in those cases these kind of defects like transverse base metal cracks may occur. Now, they may not be seen until the weld metal has cooled to the room temperature. So, many a times you need to do the non-destructive testing methods to see that. So, what is happening that when it is cooling, and then after that you do the non-destructive testing like X-ray, or have many other non-destructive testing methods. So, only using those methods you will be able to see these transverse cracks in the weld bead or in the welded specimen. Then depending upon the location of the cracks, you have another category of the crack, that is your underbid and toe cracks. So, these cracks, so they are the surface cracks in the base metal and they are under or near the weld. So, when they are the surface cracks in the base metal and under or near the that weld, so that is known as the underbid cracks. So, so if you look at, so we had seen yesterday, so if your this is your weld bit looks like, and you have the fillet weld, typical fillet weld will be shown like this, and on this side you have another plate. So, this way you have the plate which is there on this side. Now, in these cases, so you have the definition of the either underbid crack. So, when it is occurring near below that bead here, so that is the example of underbid crack. And then similar cracks, if they appear on the plate surface adjacent to the weld. So, if they are appearing here, they are adjacent to that weld. So, then these cracks are known as the toe cracks. So, so if you talk about the reasons for the underbid cracks. So, if you see the underbid cracks which are formed in the HAZ, they are due to following factors, like you have when you have relatively high carbon content or alloy content steel that is allowed to cool rapidly. So, when you have high carbon content or alloy content, high alloy content, and if it is allowed to cool very rapidly, in that case there is a chance of having formation of undesirable structures. So, that leads to the formation of these underbid cracks in the weld. And then the other reason is the hydrogen pickup. So, these are the two reasons for the underbid cracks. If you talk about the these two cracks, underbid cracks or the toe cracks. So, they will be seldom appearing with certain steel compositions, like when the carbon is between 0.06 to 0.25%, or the manganese also has 0.35 to 0.8%. So, that there is percentage range. Through that range, basically these underbid or toe cracks seldom happens. So, another factor which is promoting these underbid cracking is so one is the relatively high carbon or the alloy content. Another is the hydrogen pickup. So, that is basically pickup and retention of the hydrogen. So, if it is retained, so in those cases you have these chances. So, that basically that factor has to be kept in mind, so that these hydrogens are basically you must have the way the method, so that these hydrogen which is there they should get the sufficient time to escape out of the weld. So, if the cooling is basically rapid, in that case that this hydrogen does not have the enough time to go out, and they are trapped in the HAZ, and in that case it will be creating a condition of the low ductility type of condition, and that is also known as the hydrogen embrittlement. So, that is basically the process of having hydrogen embrittlement because of these conditions of welding in which the hydrogen does not have enough time to come out. Next thing which is what we can think about to avoid these type of defects is that you should go for the slow welding, or you may go for preheating, because one is that if you do go for the slow welding, in that case it is getting time, the hydrogen is getting time to come out. So, one way is that, and another is that you can go for the preheating. So, by doing the preheating, basically you are decreasing that cooling rate. So, that also reduces the chance of formation of the undesirable structure or hard phases, and that also reduces the chance of these underbid and toe cracks. So, when you have weld with large cross sections, so they require higher heat inputs than the smaller ones. So, so what you do is we give high welding current and slow welding speed. So, that reduces the rate of cooling, and then that decreases the likelihood of the underbid and toe cracking. So, that is normally the cases with the formation and of the underbid and toe cracks. Certainly you have many other conditions also, many other parameters are there, like you have other welding conditions are there, then joint also will be affecting. So, what kind of joint is there, how much thickness of the metal is there. So, that way that will also be affecting the amount of heat transfer that has to take place sideways. So, all these in a compounding manner affect the likelihood of these underbid and toe cracks, and accordingly you can have the proper way to control it. So, that is about these underbid and toe cracks. Thank you very much.